Hello and welcome to today's lesson. So today's lesson we're talking about another kind of transformation, and the transformation we're talking about today is dilations. So we've already done 3 different transformations and now we're moving on to a 4th one of dilations. So where have you heard of a dilation before? Have you ever heard anybody use that term before? In most kids, when you talk about dilations, you think about getting your eyes dilated and how your pupils are different sizes. So the pupil on the right here is dilated, and it helps doctors look into your eyes so that you can see things and they can make diagnoses. All right, so a dilation is a transformation that changes the size and shape of the size, but not its shape. So it doesn't all of a sudden go from a triangle to a rectangle or from a rectangle to a pentagon. So the shape actually stays the same, but the size of it changes. And what we say is it changes by a scale factor of K. So a lot of times if you ever see me writing shorthand and I write SF, I'm standing for the scale factor. Sometimes you will see people talk about the K value and how that K value is changing the dilation of the figure. So it describes how much the figure is changed, and we either have enlargements or reductions. So an enlargement is going to be something greater than 1. So if it's twice the size, then that K value would be a 2. If it's triple the size, then that K value would be 3. A reduction is going to be something between 0 and 1. So we don't use negative numbers, but we could use something like 3/5. So then that decimal value would be 0.6. So those how we do our enlargements and our reductions. Scale factor or the K value. Okay, scale factor is a lot of what the vocab that I will use. So in the book here, they're saying, what is the K value here? Remember, we have to pay attention to what the image is and what the pre-image is. So in this case, the pre-image or the image that we're starting with is the P, the bigger paper clip, and we are going to the smaller paper clip. So we can tell that that is going to be a reduction because it's getting smaller. So what we're going to do is we're going to put what the K value is going to be this number right here, 18 over the original of 30, and then we always simplify. So I think we can divide by 6 here and get a 3, and divide by 6 and get a 5. So the K value here is going to be 3/5. Occasionally or sometimes you guys like to write that as a decimal, so you just may write 0.6. That's fine. All right, so find the center of a dilation and find the scale factor. So we've got our TOK and then our T prime, O prime, K prime. So we know that this is going to be getting bigger. So this is an enlargement. We can tell that for sure because it is getting bigger. So how do we find the center of dilation? What I like to do is take these points right here, and when it's on a graph like this, it's kind of nice because then I just like to connect them. And then you do the same thing for this and you connect them. Whoa, and then the point where they meet is that center of dilation. Now, a lot of times I don't just connect them like I just did freehand. I would probably count slope so that I could be a little bit more accurate. So let's see, we went up 1, 2, 3, 4, and over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I think I said 4 over 10. So that would be a slope of 2/5. So I'm going to go down 2 and over 1, 2, 3, 4, 5. Ooh, I'm a little bit off. Okay, and then I would do the same thing from the other side and count from this point T to T prime. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we went up 10 and over 1, 2, 3, 4, 5, 6. So when we divide that by 2, what do we get? 5, divide by 2 and get 5, divide by 2 and get 3. So I'm going to go down 1, 2, 3, 4, 5, and over 1, 2, 3. And you can see that it should have brought me right to this point right here. So my center of dilation is going to be 1, 2, 3, 4, 5, 6. So I think that's at a -6. And then we went down 1, 2, 3, 4, 5, 6. So it's -6, 6. Okay, so that would be the center of dilation here, would be that point -6, 6. So a straight edge ruler or counting slope is what's going to help you find that center of dilation. All right, now how do we find that scale factor? Well, let's see, from here to here, this is just 1 unit. And if you went up and over, there would be a point here in the middle. So this is 2 and 3 units. So this one is 1, 2, 3. You can see we have 1 unit, 2 unit, 3 units from the center point. So this is going to be 3 times the size. And you can just double check that by counting. This side right here is 2, and this side is 1, 2, 3, 4, 5, 6. So we can take 6 over 2, and we get 3. Okay, so you can do it either way, but you can tell from here we've got 1, 2, 3 parts, and that's where I'm getting my scale factor of 3, or you can tell simply by the figure comparing 2 to 6. So either way will work. All right, what is the K value here? So here's our pre-image to our image. So we're going to do 1.2 over 4. And you can tell it got from the pre-image is where we start, and it got smaller. So we are doing a reduction here. So 1.2 divided by 4 gives us 0.3. All right, graphic design. A designer created this logo for a real estate but needs to make the logo twice as large for use on a sign. So what is the K value? Well, they want to double it, so the K value is going to be 2. The scale factor's twice. They want to make it twice as big. So where is P? 1, 2, 3, 4. So it looks like P is at 3, 4. So because I'm going to double it, I'm just going to multiply both numbers by 2. And so the coordinates of P prime would have to be at 6, 8, because we are doubling both numbers. So how do we write that mathematically? So centered at the origin and the scale factor of K. Sometimes I just say scale factor. Sometimes we talk about the K values. And you can see here where we just multiplied by those K values. So in that other one, what was that point? 3, 4, and underneath it I just wrote times 2, and that's where we got our 6, 8. So what we did is we multiplied both sides by 2. So we write that by multiplying by K, or that constant. All right, so what are the coordinates of K prime? So we need to focus on just where K is after doing a scale factor of 1/3. So where is K? That looks like -3, 6, -3, 6. So we need to take -3 times 1/3, and we need to take 6 times 1/3. And after putting it through that dilation, we become and find K prime. So what does that become? 3 goes into 3 once, so that's a -1. And 3 goes into 6 twice, so we are at the point -1, 2. So this is where K prime would be. It is definitely a reduction because we're 1/3, so that is between 0 and 1. The rule for a rotation, so just remember back when we were talking about rotations, that might have been lesson 3. What we do it for 180 is we just put the negative in front of the X and Y. So in this one, there are 2 transformations that's happening here. We're doing a dilation by multiplying by the K value, and we're doing a 180-degree rotation by having those both change signs here. So we're doing a dilation by the K and a rotation of 180 degrees. And so the way to do that, what are the coordinates of F prime? F prime, so let's just focus on F, is at -8, -8, what's that? -4? So we need to multiply by -1/2. So we're going to multiply by -1/2. So negative times a negative is a positive, so that becomes 4, and a negative times a negative is a positive, so that becomes 2. So F prime is going to be at 4, 2. 4, 2. This is where F prime would be. Is a dilation a rigid motion? Recall, if it's going to be rigid, it's going to stay the same size and the same shape. Is that true? What's going to happen with a dilation? Nope. The shape is preserved. It stays as a triangle or it stays as its pentagon, but the size is not. That's what the dilation does, is it actually changes its size. All right, so the last thing, just as a quick review here, do you remember how to change from 300% to a decimal? Percents to a decimal. We move that decimal here 2 places to the left, so this would just be the number 3. And if we have a decimal value here, to change it to a percent, we're going to move that decimal 2 places to the right, so as a percent, this would be 62.5%. All right, that brings us to the end of today's lesson. Good luck on your homework.